Chapter 9, Water Resources, Video 3. Surface waters. Surface waters include flowing waters, rivers and streams, and basinal waters, ponds and lakes. Ponds and lakes. About 20% of the precipitation that falls in a drainage basin flows as surface waters through the tributaries into major rivers. Discharge is the volume of water carried in a stream or a channel that increases with size. The majority of accessible fresh water is groundwater. That's water beneath the Earth's surface. About 10% of precipitation will infiltrate through the soil and rock to become groundwater, forming the water table. Permeable rock containing the zone of saturation is an aquifer. Here you can see the water being, precipitation hitting the ground and then flowing through the ground down into the saturated aquifer. Water from a recharge area flows into the sandstone aquifers enclosed by aquicludes. Aquicludes are areas of clay or shale that prevent water from passing from one aquifer layer to another. Confined aquifers often contain water under pressure that can result in the formation of artesian wells, as is shown over here. Whether a well is fully pressurized and artesian depends on topography as well as the amount of pressure in the well system and how high that pressure will go into the landscape. But any well that has pressure above the aquifer line is an artesian well. Most wells are now dug well below artesian surfaces and need pumps to bring the water up to the surface. This has caused a great stabilization in the amount of water that we have available to us, but has also caused other problems such as mineral contamination by arsenic and other contaminants that can be dissolved in deep groundwater. Two kinds of problems reduce groundwater's utility. One is discharge, groundwater pollution, as I just mentioned. Other problems are depletion, land subsidence, and saltwater intrusion. Groundwater is very vulnerable to pollution, which is costly and time-consuming to clean up. In the middle of the country, much of the groundwater has been polluted with pesticides and nutrient pollution from agricultural practices. Once these pesticides and herbicides get into the groundwater, it's almost impossible to get them out completely. In addition, groundwater can be contaminated by oil spills or leaky oil tanks that are stored underground. Once this happens, some of these oil contaminants travel with the plume of water and become contaminated. Right now, there's a big concern about fracking for natural gas and the types of contaminants that are loosed into the system and that may get into groundwater. This is controversial, as most data shows that it's not the fracking itself that causes the pollution, but side effects of fracking. Withdrawal problems occur because human pumping can remove water from aquifers much faster than they recharge. Areas where water is being pumped out faster than recharge can deplete aquifers. In this map of the US, you can see where areas where there's much higher water use than there is precipitation have completely lowered the groundwater table in these large aquifers. The Olagala Aquifer is an old underground sea, freshwater sea, and it took millions of years to charge it and then fill up. At the rate we're pumping it out, no one's quite sure when it'll be drained. Also over here, in New Mexico and Nevada, as well as the central California valleys, the groundwater is well below sustainable levels. Whereas we see here in Maine, we get recharged regularly. We also don't have the deep, large aquifers for groundwater that these other areas have. This shows overpumping of groundwater. Right? When you overpump groundwater, you get a cone of depression around the well. And this, this causes other wells to go dry in the area. So when farmers are competing for water, the person with the newest, deepest well often gets the water, and other farmers are left dry. Saltwater intrusion can also be a problem from overpumping. If the water table is here, the fresh water is denser than the salt water and prevents the salt water from infiltrating into the aquifer. Once you start pumping down the fresh water, there's a negative pressure gets below and pumps the fresh water up, and the salt water can get in below. I'm sorry, did I say fresh water was denser? That's not true. Salt water is denser. But here there's a positive pressure keeping the salt water out, and here, once you pump the water off the top, salt water can infiltrate and the aquifer gets contaminated. Obviously this happens more in dry climates near the ocean than it does in wet climates. Subsidence is more localized than aquifer depletion. Subsidence sometimes occurs where groundwater depletion causes the water table to drop. If the water-filled voids in the aquifer were large or supported by water pressure in the groundwater, the empty aquifer rock strata can compress and form sinkholes. The overlaying lands tend to sink, which destabilizes roads, buildings, and other structures. Here's a picture from a sinkhole in 2003 in Winkler, Texas. This is about the size, this is about a quarter mile across. It's a pretty big sinkhole. Here's another one in Guatemala City in 2007. Here the sinkhole isn't quite as large around, but you can see how deep it is, and that any structure that would have been here, including part of this house, is completely gone. Every year people lose property to sinkholes, and sometimes people are killed. There's a big problem in Florida right now as the aquifer is drawn down with sinkholes. In this section, we should gain knowledge of how much precipitation ends up in surface waters and what % precipitation will infiltrate through soil and rock to become groundwater. What's the primary issue with groundwater use? What are the consequences for overuse of groundwater?